Signori e signori, benvenuti.
Ladies and gentlemen, welcome to the third edition of Biotopics. My name is Giacomo Di Dadi. I'm the Operations Director and Co-Director for Big Green Technology. We are delighted to start this second session for Biotopics. Yes, Biotopics has started a few hours ago with lots of students coming. Over 120 students joined Confindustria this morning, and they attended the masterclass by Mr. Bertacchi on biotechnologies. And they're now visiting the laboratories here at the Chilometro Rosso. And that is exactly where I will be starting from. So I would love to thank you, Mario Negri, Pharmacology University and Joint Lab, and my colleague Raffaele for making laboratories available and open so that the students may really look at what they're studying about.
Da dove ci troviamo in questo momento, ovvero dalla sede di Confindustria.
So this is the headquarters of Confindustria, and we're starting from here. Vice President of Confindustria, Giovanni Fassi, I would like him to start with these institutional greetings, please.
Buongiorno a tutti. Si sente?
Good morning, everyone. I hope you can hear me okay. Good morning, everyone. Welcome to the headquarters of Confindustria. It is a great honor for us to be able to welcome the third edition of Biotopics. It is a honor that we can talk about this topic, technology, biotechnologies, innovation. Well, more specifically, as it has been said, we very much focus on innovation. So I'm happy to share all of this with you. Confindustria is paying great attention to these topics. It's paying attention to new technologies, innovation, as well as the important dissemination of these very technologies. It is therefore a great pleasure to welcome you all today and to allow open and frank conversation to take place, as well as dissemination of new ideas. I'd love to share with you an example, which might be very interesting for you to know. So, Albina and Green, which is a technology that has been well known for long years, so within the textile industry, embracing biotechnologies for the research of new pigments, new solutions, which are obviously addressing different solutions. Namely, because on one side we do have the manufacturing, more traditional aspect, but on the other side we're paying attention to sustainability, to the environment, which is, of course, what biotechnology is more about. Biotechnologies are constantly growing, are constantly evolving, and within Confindustria, so from our side, what I'm happy to say is that there's no one field of application. There's so many scopes of application, biofuels, nutrition, weaving, textile, you name it. So perhaps we should become a little bit more imaginative and creative, try to understand how to best apply these new technologies within our industry and make the most of it. I won't take any more of your time, as many interesting things will be shared with you in a moment. I just hope the whole of the day today is going to be food for thought for all of you. Hopefully you will be interested into these new ideas. Thank you so much for coming once again. Have a productive day.
Grazie mille per queste parole che tra l'altro introducono.
Thank you so much for the kind words, which are nicely introducing the very first topic that we're going to talk about today. Two housekeeping information before we get started. You clearly invited to attend more interactively this session. By show of hand, you can ask questions and you'll be given the microphone, or else you can use a Slido, and by the hashtag #ByTopic23, you can submit your questions. I will see your questions on the tablet and I will submit them to the speakers. I would love then, therefore, to tie back to what Mr. Fassi just said. So what are biotechnologies? Well, that is also the title, part of the title of this third edition of Biotopics, so biotechnologies and innovations. These are indeed the two topics that we're going to delve into. I'd love to start from biotechnologies. So we'll be hearing now how the latter can really support sustainable innovation and how they can support a great deal of industries so that they may reach out to their sustainability goals. Mr. Bertacchi, he is invited on stage, a researcher and scientific speaker and EU Bioeconomy Youth Ambassador.
Buongiorno, io qui per parlare con voi ho
Good morning, everyone. So for me to talk to you, I've just turned on my microphone, you see, because I want to be able to talk to you. And so I've chosen a light bulb with DNA, so that a light can be turned on, light can be cast on biotechnologies. And let's see, how does this tie to innovation in a number of different industries, as we said. If we try to set the context, we may perhaps define biotechnologies as organisms for the, let's say, for the achievement, for the development of a product. They might be also interesting from a sales standpoint. This is very broad description, and indeed, we are basing biotechnologies or these organisms that can be microorganism, bacteria, yeast. For instance, I do work with yeast as part of my research, or plant cells, or plant, namely for the production of something, animal cells, and single cells, which are largely used to develop biological drugs, so like monoclonal antibodies, vaccines, hormones, and so on, or even animal models, especially when it comes to medical research. Or we may even touch base on enzymes. Enzymes, in this case, lactase, which is the enzyme that people who are lactose intolerant need to be able for them to process. So many different applications, textile, nutritional, and so on. Biotechnologies, by nature, are multidisciplinary, and they're cross-referencing many different fields. And this is the reason why we struggle to understand more about it. So biotechnologies are difficult to understand, to study into, and people tend not to know the fields of applications, which are so many. And this is what I've shared with the students earlier on today. You know, they are the future of a workplace, and they must know that the most important thing, if they want to become expert in biotechnologies, they must be open-minded, being open and flexible to apply biotechnologies to many different scopes. If we start from industrial biotechnologies, they have to do with bioeconomics, and I will go into detail in a moment. So bioeconomy is using biomass to deliver bio-based products, and this is perhaps something that marketing people like very much. And again, starting from biomass, so I'm going to spend some time on it, and then the connection between the two is the biorefinery, so which is not based on fossil fuels. Often, biorefinery is based on a microorganism. So all of the processes which are using biomass are biorefineries. So if you throw wood into your fireplace, for instance, that is a biorefinery in itself. It sounds banal. You can valorize biomass way better, and nature does it. Mother Nature does it. You know, inspired by nature, the slogan, which you might like also, it is very true. I mean, microorganisms in nature, they are recycling biomass to do something, you know? This something can be something that can be very useful. We can make beer. We can do lots of other things. Microorganisms are then being equipped with a superpower by the genetic engineering, which is what I deal with, and to obtain some additional microorganisms that otherwise would not be able to do, or else to consume biomass that otherwise they wouldn't be able to make use of. And this is how we do tie back to industrial biotechnologies. So the main goal is to develop a process. Again, I may sound very vague here. So we may say that we may deliver cheese or perhaps develop a new enzyme for the tanning industry. And all of this has a repercussion on health, you know, and this is bio-directional in a way, because by using biomass, we could use more and more reduce our dependence on fossil fuels, which, as we know, have a very significant impact on the environment and, of course, on our health. And also, we could do this to further protect the ecosystems. It becomes very important to understand how do we use biomass, so also legislation steps in. This is what I do. This is the cover of my dissertation when I did my PhD. So what did I do? These are examples of bioprocesses that can be obtained. So different types of biomass, from manure to refined sugar down to byproducts and cinnamon, or manure, of course, is the cheapest one with respect to refined sugars. And this is something that you also want to take into account when you're dealing with economics. And then we do have some products. Biomethane, which comes from manure, which I've been able to use through beta-carotene, so through carotenoids. So, and then folate, so folic acid, B9 vitamin, which is an additive that pregnant women tend to take. And how did we do so? Through microorganism, a genetically modified yeast, and from another yeast, which has a very difficult name, and through the enzymatic hydrolysis, I was able to make use of that, or else biomethane through the anaerobic process. And but thank goodness, all of this was not done in a lab. I mean, I was not touching any manure, but I was using mathematics, modeling, therefore only PC-based algorithm. And, well, all of these to understand what would be the behavior of microorganisms within this process. So all of this is part of industrial biotechnologies. Now, bioeconomy. Well, bioeconomy is that, let's say, portion of the economy that has to do with the valorization of biomass. But again, biomass can be many different things. If we take a look at some research made by academia, we come across a number of different sectors that we might deep dive into: agriculture, forestry, fishing and aquaculture, food, beverage, bio-based textile, wood products and furniture, paper. Perhaps these three here, so the bio-based chemicals and pharmaceuticals, plastics and rubber, therefore fine and bulk chemicals production, liquid biofuels, bioethanol namely, or bioelectricity that can be obtained from the biomethane which I mentioned. So, as you can appreciate here, here, we also have agriculture and food, which of course account for the greatest portion here. Well, it goes without saying that Italy plays a very important role within Europe. We are one of the biggest country, largest density population, and of course we're very keen on food. So can we perhaps play even a bigger role on more technology-based industries? Food can be as interesting and technological, but of course we do have a very long-standing tradition in food in Italy, so it makes it easy for us to deal with it. So how can we valorize biomass here? Often you compare it to the metaphor of a pig when you would eat everything out of a pork, and this is the same metaphor that I would apply here. So this is a roundwood, so talking about timber here, wood, which might have different flows. On the one side, half of it might deliver energy, so it's been burned, pellet, and so on. So for heating purposes and for use by companies and so on. And another portion is delivering bioproducts, once again, either delivering energy on this cascading concept, which means that on a cascade, you are valorizing whatever is left from biomass. And back again to what I said before, inspired by nature. Nature is recycling anything. When a tree is falling, nature, Mother Nature, if you will, is able to recycle the full organic matter thanks to the microorganisms, which are, of course, making possible for the whole of the ecosystem to thrive. And this is why I love microorganisms. They know how to do a number of things. And then there's another interesting piece, which is the crop production. And a lot, of course, is going on feed and food, so food for human beings, and feed, which is food for animals. And then a small waste is being devoted to energy associated to food waste. For instance, food waste is digested in an anaerobic manner, or else it's been handled more in an industrial manner. So this is a document issued by the EU. I'm also Bioeconomy Youth Ambassador. I've been appointed by the EU last year, and often I speak in Brussels. So this is what I really love to talk about. So this is all about bioeconomy. But when we talk about bioeconomy, biotechnology is not being mentioned so much. And this is not something that I find accurate. So I want people to understand that biotechnologies is very important and is part of the bioeconomy. You shouldn't just associate biotechnology to GMOs. There is well more than that. What is this? What is this drawing? This is part of a presentation that I delivered at the European Commission last year in the Charlemagne building in Brussels. And it was a European Bioeconomy Congress, and I was presenting the bio-industry. Well, basically something that you might be interested in today. So I've kind of built a metaphor, and I've used the constellation with the different stars, And this is kind of the ending of my speech, There are different stars, kind of VIPs, detergent, energy, food, textile, biodegradable materials, waste, potentially genetic engineering, but they're all kind of disconnected from one another. And unfortunately, there's no connections because they're kind of a standalone. Whereas, as human beings, we are very good in making connections amongst elements which appear to be disconnected. And constellations are a very good example. Stars are not close to one another, of course. They are a million light years, but we do see them on the same screen, if you will. So the thing here is that, I was not I was not focusing on a special star here, but I was very much considering the whole of the screen. So it is important. The message is that it is important to deliver connections, because the byproduct, the waste of one company may become the raw material of another one. And therefore, if you're able to create connections in a highly density industrial area like Lombardy, like the plain where we are right now, you know, many different sectors, they're all strong and powerful, but they don't talk to one another. And I come across this very often. I understand that companies do not talk because they don't have that open-mindedness for them to understand that there might be a good connection.
And so the connection between bioeconomy and biotechnology can allow us to create refineries that can use biomasses instead of fossil fuels and avoid all the cascading problems. But let's not think that this is the only target of bioeconomy and biotechnology. It's not just a question of replacing these things, but it is also and especially that of creating something new, of something that is innovative with biotechnology, with microbic biodiversity, genetic engineering. We can also obtain and achieve something that is not simply a molecule that we achieve from a barrel of oil, but made with biomasses. No, something more can be achieved, something that it has been improved. Now I'm going to rapidly review a set of examples. So biofuels, I was talking to you about biofuels. Their origin is absolutely remarkable, and they come from edible biomasses that are not sustainable, because these are biomasses that we feed on, have a social impact. And so considering a progressive electrification of the world, I believe that biofuels will play a lesser role, a less important role. And then we should also understand how regulations will be developed in terms of combustion engines, the CO2 emissions. It depends on how standards and laws will be drafted and passed. So if you want to eliminate CO2, you use methanol. So the way in which legislation can impact an industrial sector is very important, because this will mean whether to invest or not in a certain industrial sector. And this is why I often go to Brussels and speak about these things. Then we have anaerobic digestion and biogases. So half of this anaerobic digestion in Italy is used in Italy. Another part goes to the waste-to-energy plants. And another part is used to achieve biogas, biomethane. And so once you analyze this with carbon 14, it is not a fossil fuel. Sorry, fossil gas. And this can be achieved in situ where you need it. And so the farm where they have the waste, so manure with microorganisms, they achieve a mix that can be directly used by trucks or by the various plants that are present on the farm. And there are numerous examples in Lombardy. Biomaterials, so bioplastics, either they come from biomasses or they are biodegradable or they have both features, and this creates a lot of confusion. And we have either bio-PET. Oh no, this is not biopet, sorry. However, this material comes from biomasses. And it's not biodegradable because it's PET, or PUR that comes from lignin, that is a waste of wood processing, or PLA coming from biomasses, and PHA, or other biomaterials that are derived from fossil sources but are biodegradable, like PBS and PBAT. And then we have biopolymers. We have numerous examples, some from Be Clean, one of the organizers of today's conference. And we have some examples here in the slide. And we get this polysaccharide that is used in different situations. So biopolymers have different applications. So biological activity or bioplastic processing. So in general, we have numerous chemicals that we can achieve and manufacture at biotechnological level. This is again a slide coming from the EU report. We have succinic acid, acetic acid, propylene glycol, that is for PAT. Some are more developed, some are lagging behind. But however, we have numerous main molecules that can be obtained at a high level. So compounds that can be achieved biotechnologically by fermentation, as you can see up here, with an GMO sometimes, or sometimes with other applications. Another example, Be Green in the textile sector, MyCHS, we have natural dyes. And this, once again, will make the marketing people happy. So bio-based dyes that can be used, avoiding chemical dyes. Well, we cannot say and claim that chemistry is bad and dirty, but we know that chemical synthesis can have an impact on the environment, etc. Once again, another example, lacase. There's an enzyme that will degrade the indigo color that is typical of jeans to get the stone-washed effect. And we no longer need to use stones to tumble down and degrade the color of the indigo dye. Again, focusing on degradation enzymes, they can use in the tannery sector. Instead of using the bird manure that was used for the degradation of proteins and lipids, well, now, today, we can use numerous specific enzymes. And we know that the tannery sector will use these solutions once they are achieved by the biotech sector. Or also wood and cellulose. It is wood. Inside we have sugars of microorganisms. They are into the structure, trapped into the structure. So we need an enzymatic cocktail, so to speak, that will break down the inner structure and allow these sugars to eat up the sugars. And again, feed. With phytases, we have a specific situation where with the phytases there is a possible solution with compounds and anti-GMOs, we achieve good feed. And also for the environmental sector, so degradation of pollutants, so oil or byproducts of oil refineries and radioactive waste. Now, again, focusing our attention on polluting enzymes, you will have heard about the degradation of plastic. A lot of attention has been given to PET. PET only represents 9% of world plastic, so really a very low amount. But there is a biochemical reason whereby we have focused our attention on PET so much. Anyhow, we have enzymes that will allow to break down PET with terephthalic acid and ethylene glycol. And so this is an alternative of chemical recycling. We have, breaking down to polymers, and the polymer is, and the block of polymer is back in the mechanical cycle, which is the more widespread at the moment. We can also think instead of using upcycling. So these two molecules with a high added value of the molecule, we can have the transformation of terephthalic ales in vanillin, which has the flavor of vanilla. In the pharma and healthcare sector, I was talking to the students this morning, well, biotechnology is really very important here. Number of companies, revenues, investment, especially in Italy, has, a high coverage here because, this is very difficult to develop genic therapy, vaccines, monoclonal pharma drugs, microbiome, CAR-T, which is a personalized treatment of cancers. When I got my thesis done, I would never ever thought that this was going to be possible. Then we also have lactase and somatotropin. So, investments in biotech. This is a chart I recovered from the investment of 10 companies in 2022, so a very close year. And what I want to highlight here is the multidisciplinarity of technology, bottom line. This is the sector and technology, ophthalmology, food, again, ophthalmology, automation, lab automation, heart diseases, manufacturing, oncology. And so we have 7 completely different sectors, one from the other. Many are operating in the medical field, and I have no idea what these companies manufacture in the end, and that's not what I'm interested in. But what I want to understand is that most investments here have funded different sectors. And so biotech is really very relevant and a huge sector by itself. The European Commission just published the trends on bioeconomy, and again we are expanding, from bioeconomy to biotechnology and back again. So they have published 5 main items: ensuring food and nutrition security, that is one of the sustainable available goals, one of the first ones, zero hunger. Managing natural resources sustainably, because all we do is fell all the trees and we get heating thanks to that, but then we will no longer have forests. Reducing dependence on non-renewable, unsustainable resources. And here, mitigating and adapting to climate change. And here, bioeconomy not only should mitigate and reduce our environmental impact, to reduce the problems we're causing to the environment, but since the damage has already been made, we should also adapt to this climate change. So bioeconomy can support us in adapting human beings to these problems. So again, mitigation and adaptation go hand in hand. And as ambassadors, by the way, we are publishing a manifesto that will be presented in Brussels in March 2024, right before the elections. So it should be a very important event. And then strengthening European competitiveness and creating new jobs. And so now let me close on by touching upon synthetic biology. This is a quote of numerous researchers, and what they state is labels are not innocent or harmless because they carry content and form the backbones of visions, of opinions. Why am I stating this to you all? Because these 3 topics that appear to overlap are these three: industrial biotechnology, in genetic engineering, so the alteration of DNA for research, manufacturing animal proteins, and synthetic biology, which involves design and construction of biological pathways and redesign of existing natural biological systems. As I was saying, these three topics overlap, and they are part and parcel of the same gear. These three wheels have to turn one with the other. The synthetic biology is based on the fact that a cell is like a computer. It has software and hardware, as in computers, we have a monitor, we have the processor, the keyboard, but without software, the hardware is of no use. And so in cells, software is the DNA for cells. If we can program something with a code, we can do many, many things with the cells. We instruct DNA and achieve certain results. And so with synthetic biology, we can therefore claim that we can sort of install new apps in a cell. What will we teach them? We can teach cells to make a molecule that is used in the cosmetic industry with rewriting the yeast central carbon metabolism cell, or butandiol, and BASF is working on that. They are a chemical giant, or Genomatica is also working on that together with Nomad that manufactures bioplastics. And so butandiol can be used to manufacture plastic, or lactic acid, PLA, can be achieved from it, from the fermentation of milk. We have milk bacteria. And this is the value on the market. Look, $2 billion in 2020, and the forecast for 2025, 10 billion. And the PLA can also be used in 3D printing, which is a very important industry. And they are an alternative to ABS, plastic threads, and which normally are achieved with fossil fuel transformation. Moreover, in the pharma company, we can achieve Cerevisiae for an anti-malaria drugs. And if we use the Artemisia annua to put it into Cerevisiae, which is the yeast of beer and bread, this is what Amiris and Sanofi have tried to do, and these are two giants in the pharma industry. And similarly, morphine, a painkiller, once again a huge market. We do this with the opium taken from poppies. And so if we use genes from the synthesis of morphine, not only do they come from poppies, but also from other living beings. This is the black rat, and we have the Epidodonus putida, which is the name of a bacterium, and these are the plants. So we have a yeast that has a gene of a rat, of a bacteria, and of 4 different plants. And, it's difficult to tell this story to the world outside, because, of course, immediately people would say, well, it's Frankenstein. But it's a morphine without touching the plant, and you can do that in a bioreactor. You no longer need to harvest the plants. And here we're saying that Professor Christina Smolka, that funded this company, said it took me 10 years to develop the first process, but only 12 months to scale up. And so the main problem is the initial part. However, it's not that easy, and in fact, this yeast cannot be produced on a large quantity. But once again, scale up is important, and as you know, research and development is the foundation, and then you can think of scaling up. The same thing can be said with the Cerevisia, because it has found resistance on the market. So let me conclude. What are the challenges of industrial biotechnologies? That can be expanded in numerous sectors. First of all, we have to acknowledge the industrial impact, the scale up. Once again, the quantity. Biomethane is highly required. Biofolate is not that required on the market. So scale up. Products and performances, the ability to convince the market, the consumers, the policymakers, a time frame compromise, results and the quality of these results, the quality of design. Thanks to AI, we can have a predictive design, academy and enterprises, how we can train and teach to students, how enterprises can train and teach students of academy that will, universities, for example, that will enter companies that will want to develop microorganisms, for example. Of course, we need to have a higher environmental awareness so as to push on market choices and political choices so as to achieve cleaner solutions. And what we need to explain is that even with the GMOs, this is a green development. It's not going against the environment. And then we have to raise awareness with public events so as to explain all of these topics to the world at large out there. So I have concluded. These are my contacts, and these are the last 3 books I just published on plastic, on biotechnology and microorganisms. Thank you very much. Please go on Slido and give me feedback.
Grazie mille, dottore. Se ci sono domande,
Thank you so much. Of course, if you have questions, you may submit them by show of hand. I do have one question for you. We saw in your presentations how biotechnologies can be cross-referencing, can be very much all across the different markets, and may touch on automation in many different industries. And at times it sounds like it is almost impossible that we can do anything like that. But because we do have many different industries here, many different companies sitting in this very venue, what if you were providing a piece of advice to any of these who want to perhaps investigate further into the biotech industry so that they may find some innovative solutions? What are the steps that they may go through, considering that Italy is made mainly by SMEs? Well, on top of reading my books, you mean? Well, yes. Well, first of all, yes, I would recommend reading of my books. Jokes aside, well, what I would recommend is that you get informed more about these very topics. I couldn't be any more comprehensive than this. There are many different ways, you know. I come from the research, and I do develop projects with many companies. It depends on what the academia rules are, because I do work in academia, and so Biotech Lab, for instance, allows many different collaborations with Pirelli. We do have one ongoing. So putting together, perhaps getting together with academia is the first step, and also taking a look at what is being published on literature, because we do disseminate all of our findings on literature so that you may understand what is out there. when I find myself talking to people from many different industries, they look at me as if they have no clue what I'm talking about. But actually, there's a conversation that may be very interesting for all. And also, why not hiring biotechnology specialists? If you look, for instance, some unconventional roles, maybe you are not looking for that role in specific, but if you understand exactly the way we do work, the open-mindedness we have, the way we think out of the box, and I think those kind of roles, those kind of specialists can really be helpful. So do not be fearful of bringing a biotech person in your company, because it might really become a game changer. You don't know. And it might be very creative for you. In Italy, we tend to think very silos as opposed to constellation mode. So this is what I would recommend, that you actually adopt the constellation thinking, And then research, of course, can happen in many different ways, and only few will succeed in the end, and that's true. But that is my piece of advice. Thank you so much. Thank you.
Bene, siamo entrati nel cuore di questa mattinata.
Okay, we're now very much at the heart of today's session. So we went through the biotech presentation. Now we're going to further delve into innovation, the international session of the event. So Mr. Tommaso Giuseppe, Chief of the Industrial Automation Lab from the University of Cassino. Thank you. First of all, I'd love to congratulate with Giacomo, and I would love to congratulate with the whole of the organization here, all the organizers. I was lucky enough to attend prior events, and I have to say that Biotopics is becoming a flagship event within biotechnologies. So it is no doubt a pleasure today of being kind of witnessing, this beautiful evolution. My name is Giuseppe Tommaso. I'm a lecturer in industrial automation at the University of Cassino. But I'm also scientific responsible for the lab within the same university. It is a kind of an incubator that we're now using to support startup companies, newly established, because of the know-how that we develop within the labs. So we try to translate all of these into companies that we may launch on the market. To date, we've launched 5 different companies within automation, batteries, and mechatronic. One of these companies has been even listed on a stock exchange. And so perhaps my role within this session this morning is very much to prove how it is important to put together innovation that has been developed in academia and then what is then being adopted more in a tangible manner by companies. Also, I'd love to take advantage of what is being said earlier on by the speaker. So the speaker very much hit the spot in terms of the key problems that companies are dealing with. So how to adopt innovations and how to invest in innovations. Because if you consider biotechnologies, he mentioned a research that was a 10-year duration. 10 years research. Of course, we do know as entrepreneurs what does that mean to make such a long-lasting investment. To be finally able to deliver results after many years. It still means big investment. It means engagement of multidisciplinary skills and roles which not necessarily are available in companies. Therefore, innovation is becoming increasingly important, mainly also in pharma companies, which is very much the focus for today's session. So we shouldn't just perhaps look at innovation as a vertical novelty, as a vertical investment, because we do know that the pharma industry has been very closed for many years. But within the pharma now, we're reporting kind of a more open-mindedness, more of a hybrid approach. So pharma is open to open innovation, and this is something that we are increasingly watching, observing. Open innovation allows pharma companies to limit the financial impact of some investments so that they may deliver the product effectively to the market. And this is crucial because it allows to work and collaborate together with innovative startups, academia, and so on. What I'm saying is that there can be a portion of the base research that can be managed, let's say, more in a hybrid manner so that it may transform, it may become a new product. This is really a kind of a revolution, which has also touched base on the pharma industry. Clusters are now becoming important for data sharing. Also, we've experienced a very critical moment during the pandemic, and all of a sudden we realized that experimentation, validation of a vaccine would actually request tons of data so that we could validate the process. We were to see the effects on a great variety of people. So these clusters allow data sharing to become more effective, and data sharing now is the key aspect in open innovation platforms. So innovation, transformation, pharma, and that also involves also the manufacturing industry, which is developing some of these, let's say, some of these aspects within the value chain. So, after this introduction, I'd love to focus directly on the session this morning. So, it is a kick-off day for joint venture, which in my view is going to be very impactful on the local as well as national, worldwide, maybe European as well as worldwide, let's say, impact, as it is a joint venture between two industrial groups, which are very important, focusing on industrial machinery equipment for the production of free dryers. And so joint venture aiming towards innovation, also because industrial machinery needs to innovate. Their new business model, which are becoming more and more important, which are implying an innovation in industrial processes. So they were mechanic at the beginning, mechatronic, they are now becoming digital. Therefore, some of these systems are, let's say, allowed as long as we're able to digitize what used to be industrial only. So more and more the need to become multidisciplinary, coping with an increasingly competitive market. This is very much the base of this interesting partnership between ITEMA and Teflon, which are officially kicking off today their partnership. Few words. These are two groups that perhaps don't need to be introduced, don't need to be presented, but because I would love you to kind of introduce this session. So, few information around these two industrial groups. You can go through these numbers yourself on the slide. Now, beyond numbers, both groups are relevant from a worldwide standpoint. So these are not local, they are international, they're worldwide. And Teflon, in specific, Teflon Science and Technology Group, founded in Shanghai in 1993, global provider for pharma machinery, supporting processes, equipment, integrated system, and engineering for biotechnology and pharma industry. The industrial focus is to supply manufacturing platforms from small molecules, large molecules, genetics, and so on. Toflon has started a number of partnerships from Japan to United States and has developed 6 manufacturing sites which are very much up to speed. Toflon has become China Toflon to global Toflon, which is supplier of not only of machinery but also services and solutions. So it is not just providing the equipment itself, but also all of the services which are tying to the manufacturing process. The other company, or the other group, is ITEMA. ITEMA is from home, literally. Quickly going through numbers, their numbers as well, for those of you perhaps do not know so much about it yet. ITEMA is an Italian multinational company, leading brand in providing weaving machinery services and solutions. It is the one company that it is providing the top 3 best machinery, wide portfolio of products, and constant commitment to research for innovation and technology advances for its looms. ITEMA has majority shares from Lamindex, global brand in finished products and composite material. The subsidiary ITEMA Lab is basing its experience on electronic mechatronic processes, allowing a multidisciplinary hub that has become a privileged stakeholder for many different companies whenever consultancy on innovation sustainability is needed. So as you can see, it is joining together skills and not only that. So I would love to call the president of ITEMA, Gianfranco Ceruti.
Per un saluto di benvenuto ai presenti.
So that he may deliver his greetings. My name is Gianfranco Ceruti. I am the chairman of the board of directors of ITEMA. I'm very proud being here, speaking on behalf of all the partners, family Torre, Arizzi, who have been partners for this company from the very beginning. I'm here to celebrate this important step in the development of the group, the collaboration with Toflon, industrial important Chinese group, and therefore a Toflon ITEMA joint venture really stands out as a key moment in the diversification pathway that we've undertaken. We're positive it would deliver benefit and development to all of the territory which are engaged. Thank you so much for being with us today. This is a new target that ITEMA was able to hit. This is something that we all consider as an example of Bergamo excellence and Italian excellence. I'd love to thank our managing director, all of the directors, ITEMA Lab, for the incredible commitment that they've always made in collaboration with the Chinese staff. So thank you, Professor, and I would love to congratulate with the presentation that has been delivered by Professor Bertocchi earlier on, talking about biotechnologies. Let's say that we're not directly interested into what was presented. What we're interested in is producing something which is absolutely sustainable right now. Thank you. Well, biotechnologies will no doubt positively contaminate all of the industrial fields, no doubt. Now, greetings from Anthony Zhang, and I'd love to share the video.
大家好，我是东富隆科技集团有限公司的董事长郑晓东，很高兴今天能给我们新成立的合资企业送来祝福。以他玛是一家全球领先的先进制造解决方案提供商，提供包括一流的制造机、配件、节综合服务。以他玛在全球范围内100多个国家设有分支机构，已经有提供超过30万台织布机，是一家拥有200年传统的优秀企业。东富隆成立于1993年，总部位于上海，是一家为全球制药公司提供工艺服务、核心装备及工程的整体解决方案提供商。东富隆秉承天道酬勤核心价值观，坚守专业技术服务于生物医药的使命，以系统化、国际化、数字化的发展战略在不断的前行。东富隆和以他玛成立的合资企业将用东富隆在药品的包装设备专业知识，以他玛在机械行业的丰富经验，专注于打造优质注射机系统，为欧洲客户提供更快的服务和更好的服务。合资公司的成立是一个历史性的时刻，东富隆将继续与以他玛深入的合作，携手同行，共同开启一个全新的旅程。最后，我祝我们的成立的合资企业蒸蒸日上，不断创新，快速发展。谢谢大家。
Bene. Dopo il saluto dei due presidenti,
After hearing from the two presidents, I would love to call on stage Mr. Chang.
I switch to English if you don't mind, because to present Mr. Chang, please, you can come here, and also Mr. Ghilardi, CEO of Itema. So with them, we will try to go a bit deeper with the peculiarity of this joint venture, and to maybe better understand which is the industrial roadmap and the strategy of this new company. So I start with Mr. Chang. I kindly ask you maybe to introduce yourself and describe the mission, the value proposition of Teflon. Maybe it can be interesting, you know, as value of the contest. Please.
Yeah, thank you for this opportunity. First, I work in Teflon, take a responsibility for senior vice president of Teflon Group, take major responsibility for Teflon older international business developments. I personally joined this company since the year 2004. Actually, this company, growing from China, is really 20 years ago, make great effort from the China Teflon to global Teflon. So a lot of the hard job in the past 20 years, growing from China to the Asian markets, then to the emerging markets, and then step by step to the Europe and the USA. These are highly regulated markets. Because Teflon the equipment in the beginning is working for the aseptic processing equipment. Actually, in GMP, in FDA, this is the most strictly regulated area for GMP quality manufacturing. So we did a lot of learning in the past, and step by step, to learning how to working for the better quality and the high standard pharmaceutical equipment to save the life for the patient. So in terms of Teflon, the mission and the vision, actually this company growing from the lyophilizer technology innovation. So now and in the future, this company more and more working for, it's like a comprehensive pharmaceutical equipment supplier. So we have many the improvements or innovations in the past. Because today we see the pharmaceutical customers, their drug innovation really growing from the small molecule to large molecule. Today we are talking about biotechnology. And also in the future, we'll go to the cell and gene therapy. In Europe, we call it the ATMP. So as an equipment supplier, today we put all the value and also the responsibility more and more into the drug manufacture science based on the two important studies. One is drug manufacture science study. The second one is also the process equipment manufacture study. So this is the combination and the synergy to working for the advanced drug manufacture platform or technology to the, we call it the future or next generation drug manufacture. So in the future for Toflon, this company more and more working for is the, we call it the smart pharma factory building. Inside we call the M plus E plus C and AI, means we put our the key technology innovation into the critical process machinery for pharmaceutical applications. The second one we see in the large molecule and also the CDT growth, more and more working for modular engineering, compared to the traditional engineering model. And third one, to make the drugs more and more affordable, very important, we will supply good quality and affordable bioconsumables, like the bags, media, and the resin. So, and also more and more empowered by the digitalization. So this is the synergy and the technology combination we are working for to build this, the next generation drug manufacturer as the vision for this company. Thank you.
Thank you. Really interesting. I'm not going to ask Mr. Ghilardi to introduce himself. Maybe you can do, but I think everybody know you here. But I would like to ask you to describe how and why Itema has brought to life this joint venture with Toflon.
Yeah, thank you, Michael, for your words. First of all, I want to say thank you for all the people that during these 3 years work in Toflon, in Itema, on this project. It was not so easy, we know, arrive at this stage for different reasons. For sure, the COVID didn't help us properly during this period of time. But I want to say thank you really to all my people in Itema because they did really a great job and they never lose the focus to arrive at the target of the joint venture. For sure, the shareholder of Itema was really involved in this, and I want to say thank you to all the family and the shareholder family here. I know that it's not so easy diversify the group, and I want to say thank you really to all of you for this opportunity. Why? We understood during our process two things. The first thing is that we need to be better and better and better in our own field. Maybe in our weaving field. We must be more innovative in our weaving field. For this reason, 3 years ago, we developed a spin-off in our group. We built up Itema Lab. With Itema Lab, for two reasons. The first reason is to become more and more innovative in the weaving machines, for sure, because the weaving machine is remaining our main business. And the second one is to develop the industrial application. And this industrial application will lean more on the ability to engage ourselves in different technology. For this reason, we develop Itema Lab Industrial. And for this reason, when the Radici family gives to us the possibility to work on this project with Toflon, we establish in Itema Lab this possibility. This is the first reason. The second one is for sure the innovation. because we need to diversify ourselves, not because we are not interested in go ahead in the weaving machine, but because we understood that if we want to grow also in weaving machine, we need to have more others possibility to learn technology in different fields. Here we speak about biotechnology, but it's the same for biopharma, and as he mentioned, is really important. These are the two reasons why we start this activity. Thank you.
Yep, thank you. Now back to Mr. Chang. Which are the ambitions and the goals of the Toflon Itema joint venture?
Actually, as a company, if I can say, it's a dream to working for globalization. We chose the very important strategy many years ago. Actually, in the first step, is working for globalization, it's a localization. So if talking about Toflon, the European localization journey is starting from the year 2007. Did a lot of step-by-step job. Actually, today, this moment is not happens just one day ago. It happens in the past many years, continuous efforts. So we did a lot of equipment sales first in Europe, in the USA. Now hundreds of the equipment already in Europe and the USA passed the EU GMP and the USDA inspections to meet the highly regulated markets, the quality standards. The second, because for the equipment, you need a lot of trust, reliable partner support for the technical service. So we did the job in Bergamo, Italy, to build the regional, the service hub to offer the locally sized service support and technical support. Meanwhile, in the USA, already built also in the New Jersey, the Toflon USA, for the local support. So in the past 3 years, COVID-19 epidemic, I think changed our life, actually also changed the world. From the Toflon, from us, we learn more and more. After COVID-19 epidemic, globalization become more and more important, regionalization. Means local for local. So today, for the joint venture, the Toflon 8, it's very important we develop the solution for customer, the biotech company. So this is the joint venture. We try to synergy. The best come from China and the best from Europe. From China, we bring the very well-proven and the mature 13 years learning lyophilization technology and skills into this joint venture. And meanwhile, we are very happy and lucky to working with the EDAM lab, because this company, this partner, is really have the very modern and mature management in the manufacture system. And meanwhile, very dynamic innovations in the lean manufacture in the regionalization. So this synergy, we are looking for very competitive solution for the biotech company from the advanced technology and the European quality manufacture, also more and more digitalization, and also totally locally based and the faster technical support for the customer. Because all these the effort and the solution to help our customer faster time to market, to offer their success from the clinical study to the faster commercialization. Thank you.
Yeah, thank you. Now a question for Mr. Ghilardi. Which aspects Itema contribution will mainly focus into the joint venture development?
Yeah, in the joint venture, we have different steps. We plan these steps during these years. In the first step, we will take care 2 pillars already mentioned by Michael. The first pillar is for sure quality. Quality. Because with Teflon level of quality is already good, and we want to improve this level of quality thanks to the European standard and thanks to the European innovation. This is the first point. This is total quality approach, not only in the process, but also in the machining building up, in the digitalization of the process. All the aspects will be our first focus in terms of quality. The second one is linked to the lean manufacturing, as mentioned by Michael. For sure, in ITEMA, we are familiar with the lean manufacturing approach. And during this year, also, we open a discussion between Teflon China, ITEMA China, in order to discuss about lean manufacturing and make already some improvement inside in the system. Thanks to this, now, this is the second pillar that we will take care to develop lean manufacturing also in pharmaceutical equipment. This is really important for us in this moment. Then for reduce the problems and for sure reduce also the price. This is one of our target, to reduce our cost internally and to make more quality. For this reason, I repeat, two pillars will take care. One for sure is quality first, and on this we will work hard. And the second one is the lean manufacturing approach.
Okay. Thank you. Back to Mr. Chang. Teflon has a valuable experience and positioning in bioengineering solutions. Also, this solution will be included in the Teflon ITEMA scope?
Yes. One background is in the past 3 years, COVID-19 epidemic, Teflon did a lot of deep involvement for the COVID-19 vaccine manufacture. In China, for the two leading COVID-19 vaccine, from Sinovac and from also another one, most of this the bioengineering equipment come from Teflon for COVID-19 vaccine. And furthermore, we also did a lot of technology and equipment supply to many of the emerging markets, also including the Resi Pharma in France, in Morocco. So in terms of the roadmap and the strategy, we look at 2 parts. The first part, we see in drug innovations. We see in the following years in our industry, worldwide, large molecule, and also the cell and gene therapy will be the growing tendency, become the mainstream in the innovations. The second one, for the joint venture, the Teflon 8, in the drug manufacture science study, we see the tendency is very important, the growing tendency, it's the system solution orientation. We see in the 3 fields. First, we see in the DP, in the fill finish, no matter for the vaccine or for the antibody. Because in the past years, we already see in this area, the tendency will be the automation and isolation. Means the upstream equipment to downstream equipment become more and more close. We call the system integration and also continuous processing. So this is the one. The second one we see in the upstream, the DS, we call the drug substance for the bio API manufacture in the pharmaceutical sector. Because today, the process, the tendency become more and more intensified process. We call the process intensification. In the cell culture to purification, more and more from the fed batch to continuous processing. So that means from the cell culture to the harvest, to the separation and purification, this processing more and more closely and integrated because of the continuous processing. This is the second learning and observation. The third one is we see in the next generation for the cell and gene therapy, because it's really from the patient they are the blood separation, go to the gene modification, to the also the incubation, to the final the feeding process. All these the cell production process need the whole process is aseptic and closed system, because they will be built in a pharmaceutical facility, also will be built in an oncology center. So this is the need a very integrated system solution. So this is the way we see in our the biotechnology in the future. Very important, the tendency is a system solution integration. So this is why under this umbrella of this joint venture, EDAM and Toflon, we are already discussing the strategic roadmap. Lyophilization innovation is only the first step. More and more important, we will present the solution from the lyophilization or free drying, go to the DP and to the DS, working for this integrated system solution. Because this one really will be help the biotech company. They have the very advanced drug manufacturer, the support for their success. Thank you.
Thank you. So last question, at least by my side, to Mr. Ghilardi. So you have been appointed as president of Toflon Itema. It's well known that Italy, Europe have an important heritage on biopharma. How do you think that integration, mainstreaming of the joint venture could be developed within this framework?
Yeah, this is really a good question. But for sure, we know Italy, in particular in Europe, have a great knowledge in pharma, in biopharma. Also in this session, there are different interesting people for the pharma in Italy. I think that one of the target of the joint venture is try to set up a competence center and the joint venture research and development that can combine what we are doing in China in this moment and what we will do and we can do in Italy. For sure, this is an important step. It's not the first one, for sure. We need to consolidate our factory that you can see here in Novara. But for sure, we are looking already to understand in which way we can combine the Italian knowledge that have different important area like Milano, like south of Lazio, Latina area, and others to understand in which way we can put together the technology. This is an important point. In this way, for sure, our responsibility as Italian part of the joint venture is try to open much as possible this relation between Toflon Itema and all the actors that we have in Italy in different way. This is the first point. Second, we are in the business, we know very well in this moment the geopolitical situation is not helping. There is a difficult geopolitical situation, not only for the war, unfortunately, but also because there are these local and global, and it's difficult to manage the situation where the situation can change tomorrow or the day after tomorrow. But we believe strongly that at the end, the cooperation is the right way for develop our company, our business, and for develop also the sector that we are looking for with Toflon. For sure, it's not easy, because making cooperation is more difficult than to work alone, for sure, because you need the method, you need to understand the others, you need to understand which way you can risk less, you need to have a risk management. There are different points that you need to manage, but in the other way is the only way that we have really solid for develop our group. In this way, Itema will do a job with Toflon in this joint venture for try to open much as possible the technology approach in this important field, because this field is important for all of us. Also, you can consider what we see regarding the CAR-3 molecule approach is really incredible what is happening. For this reason, in one hand, we are really proud. In the other hand, we know that me and my colleagues, we have a lot of job in front of us, but we will do our best for reach our target. Thank you very much.
Yeah. I think it's a big challenge, but this joint venture, I think, is a win-win partnership. So really good luck for the joint venture. Before closing the session, we'd like to know if there are any questions from the audience, from the press, in Italian, English, or whatever language. Everything is clear. Just looking forward to see the evolution of this joint venture. Okay, so thank you very much.
Sorry, Giuseppe, I can see one thing because we never say, but it's important. We believe that in April, May, probably, we will have the grand opening of the factory, not for the production, because the production already start, and Ted, that is the CEO of the Toflon Itema, is here and is remaining here in Italy for a long time. Thank you, Ted. We will have this grand opening, not only for our internal job, but for our customer, for the Italian customer, European customer. We are planning this, and probably we will invite you to visit also our company Novara in the next months.
Yeah, exactly. I just add a few words into the Ugo. I think it's very valuable announcement. We looking forward to bring everyone and also a customer to visit this facility. It's not only see the equipment, to see more than equipment. First, to see the quality system. This is the number one. The second one, we really working together to build this facility is the competence center. That means you can see a lot of solutions. The solution will come from many of the best practice in a small molecule, for example, in oncology, in a complex injectable, liposome, microsphere, and also many the new administration delivery system. The second one, in a large molecule, you will see a lot of best practice in an innovative vaccine, the application, and also in a monoclonal antibody, and also in the ADC, in a CAR-T. So we're looking forward to share the best practice learning and already the good solution for the biotech company, also for you in your clinical study, because you need very good technology to find, okay, I have some better way. The second one, also very efficient and competitive solution to support you fast to the market. Yeah, this is the valuable solution we are looking for. You will see in the next step. Thank you.
Great. Thank you. So if there are no any other questions, I kindly ask you to stand up, and behind the new logo of Toflon, Itema, shake your hand. Thank you. Chiedo a Giacomo di riprendere lo stage.
Grazie.
Io ritorno al mio posto, grazie.
Grazie mille. Bene, direi che questa mattina abbiamo toccato un po' quelli che sono un po' le due tematiche.
This morning, I believe we really touched upon the most important topics that deal with the biotopics. When we started to talk about these things 3 years ago and talking about biotechnology for the industrial sector, well, it's an innovation aspect. So biotechnology is very important, and joint ventures will give more food for thought. So biotechnology, innovation, and bioeconomy will be very, very important. So this is why I'd like to invite Professor Marco Taisch, President of the Made in Italy Circular and Sustainable Solutions. Then I would like to ask Professor Giuseppe Tommaso to stay on stage. I would like to invite our bioeconomy ambassador and Giacomo Ghilazzi, the president of the newly founded Toflon IT. So this rounded table will be started by asking Professor Marco Taisch to explain why MICS was founded and how it works. Yes, MICS stands for Made in Italy, Circular and Sustainable. 14 partnerships that have been funded by the Ministry of University and Research, thanks to the National Plan for Recovery and Resilience. And we research Made in Italy sectors of 4 A's. Alimentazione, food, design, furniture, fashion, and mechanics. These are all industrial sectors that start with an A in Italian. And so we focus on around 55% of Italian GDP. These sectors directly and indirectly with their spin-offs that they generate. So logistics, for example, ICT, for example, that is outsourced, finance, that is linked to these 4 sectors. So this is the impact of the GDP generation for Italy. Moreover, we have also 54% of industrial investment coming from these 3 sectors. And a similar figure can be considered when speaking of headcount of jobs. So an important part of Italian GDP and Italian economy. There are 12 universities, Politecnico in Milan and Turin, the University of Bergamo, Brescia, Padua, Bologna, Florence, Roma La Sapienza, Naples, Federico II, Polytechnic of Bari, and 13 companies which also participate to this MICS partnership. And one of these is Itema, and we also have other companies. We have Leonardo. Other participants are Thales Space Economy is an important Made in Italy company, even if it's not as well known in terms of the knowledge of consumers. We have Cavanna Packaging Machinery and Manufacturers, Sacmi Machines for Tiles. We have wood machine companies, and we have additive manufacturing companies. Fashion, again, represented by the F Group, known for Moschino, Natuzzi for furniture. And we also have the experimental station for leather in Naples, that is like a research hub that unites public and private groups. And then we also set up a group of so-called stakeholders. We have more than 250 players, districts, clusters, groups, bodies, enterprises that participate to the ecosystem. So what do we perform? Well, first of all, we provide research to achieve new products. We have to research and innovate, applied research, The project is 3-year long. There are 150 million investments coming from the Ministry of Research. 70 million goes to academia, universities, 25 million to enterprises, those that I stated before, and the rest go to dissemination and raising awareness activities. So why do I want to introduce this project today? Well, because biotechnology is one of the topics we delve upon. We have structured this project on the whole life cycle of products. So starting from the design of products, and made in Italy, there are numerous activities. Biotechnologies are used to design new garments, new machines, tool machines, or plants. And then new materials. In biotechnology, new materials are truly important. We've seen some examples already when we saw the textile industry. But think of something that goes even beyond those sectors that we have portrayed this morning. Let's imagine toolings for biomanufacturing, or tools or machines for biomanufacturing. Italy is the second manufacturing country in Europe for machines. We are ranking first, second, and third at international level for machine manufacturing. And if we want to keep up with this, with maintaining this leadership, we have to continue to research and innovate. So the challenge here is to exploit competences and skills in mechanics, but of course push towards innovation. And this is where we can really expand and exploit biotech. We also speak of additive manufacturing. So this is another item, another topic that I'd like the expert to touch upon. I think of metals here, plastics, polymers, and probably Stefano, we should also think of other fields of innovation. And let's also think of factories. How are they designed? What is their layout? This is my competence. How will they need to be designed so as to exploit these technologies? The factories will have two dimensions. Today, when designing new factories, we already imagine the factory in outer space, factories on the moon. That's a new topic. Gravity there will play an impact. We exploit gravity on the Earth to do many things, to manufacture many things for compounds, for example, so that they get directly to the operator. But out there in space, gravity is something else. And on Earth, gravity becomes a constraint. And in space, this will no longer be a constraint, and it will no longer be two-dimensional, but three-dimensional. So this is another opportunity we need to focus upon. And then processes that we design on the Earth that have a negative impact from gravity, which will feature new characteristics if imagined out there in space. And what about business models? Are we sure that these business models that we've used up to date to sell traditional products vis-a-vis or versus innovative products where biotechnology will be a fundamental component, will still work in the future to sell these different products, those that were not used to have yet. So maybe yes, maybe not. This is where innovation, once again, has to be understood with other meanings, not only technological innovation, but out of the box, 360 degrees of product, of factories, of supply chains. You spoke of the globalization or redesigning globalization. How will international value chains be designed in the future? Up to now, they were designed in a certain way because we were used to work in the traditional manner, but in the future, they might be different. So we really need to think out of the box, be open-minded, and think 360 degrees. And this is what we do at MICS. Well, thank you, Professor Taishi. Now I'd like to leave the floor to Professor Tommaso. You have already introduced the task at hand in your automation lab. So what are the challenges that you are tackling with right now, and what are the possible solutions that you envisage? Well, yes, as I was saying, our lab, on one hand, performs research, academic research, and on the other hand, we try to put this research into practice at industrial level with startups and spin-offs. Our main focus in the automation lab is electronics, industrial automation, given that electronics is integrated in production and manufacturing right now. One of the new challenges that we are seeing and that we are trying to gather skills and competences around the hub that manages also numerous networks and connections with other research institutes and universities. And so here, one of the challenges is understanding the impact of industrial electronics and consumer electronics on the environment. One of the main problems that we are seeing lately, on which we are trying to raise awareness in the industrial sector, is the low level of recycling of electronic devices. So electronic devices like smartphones, for example, that have to have a short life cycle. In the past, they had a longer life cycle. But also power electronics, the size of material and consumables that will have to be designed with a longer life cycle for these electronic devices. So conversely, in the past, we want to have materials that was resistant in time. So we see that our smartphones, for example, heat up under high temperatures, under sunlight, and deteriorate the components of these devices. If we move all this in mechatronics, in automation, we see that in a larger scale-up size, these components are omnipresent. And so systems see that electronics is more and more important. These devices have to have at least 10 to 12 duration. So it's no longer consistent to have a 10 to 12 year revamping. So in the future 3.0 industry, research is moving towards the research of looking for synthetic material that have a longer life as their target. The fact that we will not change mechanic and insulation characteristics in time under heat conditions. And so now we are seeing tons and tons of electronic wastes arriving not only from the consumer world, but also from the industrial world, because after 10 to 12 years, we have to revamp industrial processes. And we are seeing an ecological problem. And this is why the European Commission has started to really focus on a roadmap that will envisage the shift from the so-called FAS substances that are used in electronics, but also in textiles, which have durability in its structure, so a low biodegradability, and shift, as I was saying, to the use of innovative material that sees biotechnologies as a foundation. But this requires a compromise. If I have substances that will allow me to use displays, screens, monitors, to have a longer duration in time, on the other hand, if I want to substitute them and replace these materials with biodegradable material, I have to be aware that they will no longer have such a long life. So the electronic industry is really in a sort of chaotic situation. When this new standard was being approved, the electronic sector is not envisaging a solution. There are many solutions that are being studied, researched, but not many of these find a technological application. How can we have wires, connectors being built in a different way? And these have a very low recycling ability and possibility. Only 10% of electricity and electronic material can be recovered or recycled. The rest, the 90%, can be recovered maybe, but at very high cost. And so it's difficult to strike a balance between the environmental to cost balance. And this is a challenge. And I see this and I'm studying this in the application way, manner. And I'm looking for replacements. But those who are studying electronics are really finding a hard time to offer a solution in this field. Well, thank you very much. And so, Professor, let's go back to materials. These are very, very important topics because it's no longer enough to change material, but we have to change the whole context, materials and also business models. Professor Bertacchi spoke of biotechnology and bioeconomy, but it is a very complex situation. Can you really go more in depth when speaking of bioeconomy? Which industrial sectors will really be able to leverage this development and how to better develop this business model, these business models. So bioeconomy, using biomasses. So biomasses have an organic source or origin. And so if oil was considered biomass in the past, this is no longer considered a renewable biomass. We do not have 1,000,000 years for this to be considered as such. So we have to focus on other biomasses, plants, animals, microorganisms, etc. As we saw on that chart, we have numerous sectors that are involved. However, it's not that this means that these are going to be a sustainable directions. We know that there are many possibilities, but in fishing, for example, in nurseries, we have environmental problems. In the wood making industries, we also have a problem of sustainability. And therefore, we need to understand net zero, carbon zero solutions. No carbon emission is really a very difficult feasible solution. Net zero or zero emissions, well, there's a difference, even if people consider these two things as the same one. And this is not banal. For example, tobacco, it's a plant, but then, of course, there are all of the consequences when exploiting this plant. Agriculture, food, these are very important sectors that make it really difficult to consider possible solutions. They're very, very important sectors. Biomanufacturing, fine bond chemicals. We've spoken of pharma today, and we might wonder, but biotech has positive consequence in bioeconomy. Can we consider biotech bioeconomy? And at the EU level, they are also wondering about it. They do not know whether this is the same thing, bio-industries, bioagriculture. And so it's difficult to find, the boundary. It's really very complicated to find boundaries. It's too faded. How do we classify human living beings with taxonomy? Constellations, they do not exist. We consider them as existing as human beings so as to understand what we're talking about, or else we would not have a taxonomy. So, bioeconomy. Many are bioeconomy sectors, not only chemistry or gene chemistry, but there's a link. Then we were thinking of e-waste right now when Professor Tommaso was talking. And I was thinking of, numerous possibilities for materials, for biodegradable material. And, communication is very important. One of my books focuses on this topic specifically. Bioplastic. Oh, it's biodegradable. It's we found a solution, but it's not a solution. There's a trap, because there's still something that will end up in the environment. No, even if something is biodegradable, it should not end up in the environment. I give the example of the typical six-pack beer, and there is the fish that is trapped in the six-pack beer. And they presented this as biodegradable, and we saw the fish eating this. I do not think that a turtle, when feeding on a biodegradable plastic, will be healthy. We really have to understand that we should not allow that biodegradable plastic enter the oceans. It should not be mismanaged. It should not be littering. We should not mismanage plastic. This is the problem. This is what requires management. So we have to create supply chains that are bio-designed, a process that is electronic, that can be assembled. So on the one hand, we have the governance and the responsibility of companies that set up supply chains that can dispose of these potential materials and think of biotech solutions. Aciditiobacillus ferocitans. It's bacteria for gold that oxidates pyrite. And pyrite is something that can be oxidated. It survives at low pH, and it finds a small-scale solution and application to manage e-waste and then leaching and be-leaching that is created. And so why is this important for bioeconomy? Because we focus on microorganisms. So is microorganism a way in which we can calculate this idea? So as an ambassador, I'm trying to consider outreach, how to talk to the audience, especially in the East or Far East, that are sometimes excluded from the storytelling when we communicate, or in the Eastern countries of the European Union. And then we should also carry out internal advocacy. Please focus on these aspects. So another of the goals of our manifesto is how to leverage and lobby the European Union from the inside. I'm not that young in the bioeconomy young ambassadors organization, but we are focusing on many different aspects. So even from the inside, we really want to see how to examine all of these aspects and allow all of these things to be important for the planet.
Allora, è già uscito tante volte questo tema stamattina.
This is a topic that has been raised today many times. So sharing amongst generations, close generations. We spoke about contamination. I do have a question for Mr. Ghilardi. How important is it for a company, new or existing? So how important is it to explore what is beyond their own business? Well, if we put together everything we heard of so far, we clearly understand what are companies faced with. Today, companies are all to share, are all to protect, first of all, the business continuity. This is what my head of operations always says. So safeguard, protect your business continuity. And that is task number one. So as you do so, you want to do it in a global context, which is the one we're faced with. So starting from 2019 onwards, we've experienced many different changes, one after the other. I don't want to call it a permanent crisis. I don't like to call it as such, but it has become our new normal. This is the new normal that we're faced with as people, as individuals, and as companies. So task number one is to protect the business continuity, but also the second task is to innovate, as Marco said, Giuseppe said, as Bertacchi said. So there's a number of scenarios where innovation doesn't have to do with the process or the product only. Let me remind you that when a company was considering innovation a few years ago, it would either be to innovate in a process or in a product. Full stop. Whereas today, innovation has to do with the business model. And this is a new battlefield. And either we will be able to kind of change our skin, or else we will collapse. And that is the bottom line. Then, of course, there are many shades to the gray color. We don't want to say that is either black or white. So on top of protecting the business continuity, the company will have to innovate. Innovate not just in the process, in the product, in a vertical manner, so to speak, but also the company have to reconsider their business model and innovate in it. For them to do so, open innovation is crucial. It is crucial because there are enabling technologies, innovative applications associated to digitization, and then the circular and bioeconomy, evolution in the production footprint, because they might come from different countries and they might all have different impact. You know, companies nowadays are trying to rearrange their production footprint in a constantly changing scenario. So it is like what is happening every single day. This big wave of change is even stronger than the gravity itself. So when I say that open innovation is crucial, although we all know that it costs a lot because there's so many people involved, commitment needed, roundtable to be attended. Within ITEMA Lab, we are attending so many roundtables talking through open innovation, but we've realized that this is crucial for us to do so. Unless we're attending, we will not be able to understand. And there will be things that will be missed, you know? Some items will still be missed, but we want to miss the least possible. So, when it comes to companies, especially if it's OEM-based companies, like in the case of ITEMA, so within ITEMA, we have a very vertical production, which is the backbone of who we are and what we do, and that is something that it also impacts the supply chain. So these are all aspects which we have to keep into account. Even if we have limited resources, we don't have unlimited resources. Well, some will have more, but we all are dealing with the limited resources. And that should help us understand what are the evolution steps that we may execute, that we might put at stake. And because the resources of one company will not do as good as resources put all together, so this is why open innovation and open business will become crucial. If we were thinking to enter the pharma, which is so complex, so if we were considering to enter the pharma unless we were partnering with somebody focusing on pharma as on the core business, well, we would not be able to cope with it. You know, we would never be able to explore the pharma industry. So what I'm saying is that perhaps we have 10 years of big transformations ahead of us, 10, 15 years. I think that is the timeline. So 10, 15 years of large transformations where we will need to change our skin, or again, we will collapse. I would love to go back to what has been said, perhaps exploring some details now. If we were convincing a company today, what are the pros, the advantages for a company to adopt a made in Italy approach? You know, sometimes circular made in Italy, circular and sustainable made in Italy sounds like a slogan, but we don't want that to be just a slogan, right? We want to convince a company that that is the way to go. Let me just turn on my microphone so I will be able to answer.
Dovremmo partire dall'accendere il microfono.
Okay.
Prima considerazione.
Well, first of all,
Noi ci riferiamo, visto che parliamo di generazioni,
because we're talking about younger generations also.
pensiamo ai nativi, ai ragazzi, agli
If we
adolescenti.
consider today's teenagers, 20-year-old, they're being considered native digital, and this is fine. That makes sense.
Se ci pensiamo, queste persone sono
These
nate
people
avendo il digitale in
were
qualche modo
born
come
with the
parte
digital
integrante
being kind of embedded in their DNA, psychological, emotional, cultural.
E se li confrontiamo con
If
generazioni
we
più anziane,
compare these people with my generation, for instance, well, to me,
proiezione di un
digital is a projection of a physical world. You know, when I started to play, I would play, my toys would be Lego blocks and so on. And then I became acquainted with computers in my 20s. So you can easily tell what is my age now. And then as I grown up, I became acquainted with all of that. But if you take a native digital today, the perspective is completely different. So they're embedded in the digital one, and the physical world is actually a projection of the digital. So it's quite the opposite as what we were born with. So this should help us understand how to approach this time with consumers. But things are getting even more complicated because these young people are native digital, but also sustainable digital natives. So they're very much into sustainable aspects. And sustainability is part of their culture. My daughter is 13 years old.
9 anni fa
9 years ago,
era 4,
she was 4, it was winter.
abito fuori
I live in the outskirts of Milan, in a small town. And we were doing the Saturday shopping. We went in a car. And I said, okay, stay there. I'll go to the laundry. I'll come back. It was winter time. I let my car on. And from the back seat, she said, don't do that again. What did I do? Don't do that again. Well, now, because there are sometimes dads forgetting their children in the car, then I was afraid that she might be fearful of that. And she said, well, you left the heated on. Of course, it's winter time, you're in the car. Well, but you're polluting. And if you're polluting, you will worsen the ozone, and glaciers are melting, seawater levels are growing, and we're all dying. Now, all of this, it was the storytelling that she had been told in the kindergarten. Now, irrespective of that, you can clearly understand that in 10 years' time, she will be a very attentive consumer. She will be a super informed consumer. So greenwashing is something that these guys are absolutely familiar with. So it's not that if you color a package green, they will buy it. So my same daughter, we were in Milan, and there was this delivery truck, and it was all green in color. We delivered this home in a sustainable manner, and so on. But it was a truck which was diesel fed. And then he said, Daddy, they make a fun of us because this is not sustainable. So the truck. So that is the kind of comments that these people are coming up with. So circular economy and sustainability is no longer an added value or some competitive advantage. This is the mistake that we should not do. This is really becoming the prerequisite for you to access the market. Either we're making products which are green, circular, sustainable from day one, otherwise we will not even access the market. I'm currently working with a company that is manufacturing wipes, and their their customer, which is a large distribution chain in Germany, implied to them, so make the mandatory to print on the packaging the environmental impact of that very wipes pack, measured on CO2 emissions and so on. So this wipes manufacturer, he went to OEM, making the machines, which is literally delivering the wipes. And I said, so here's your machine, able to tell me the energy consumption and so on and so forth, because I have to report it on my packaging. And this gentleman, he went to the digital platform that is controlling all of this data. So what is becoming evident here is the bonding between sustainability and digital. It is no longer possible to do circular sustainable economy unless you go through all this process. And so sustainable and digital, the two transitions, they are literally one ingredient of the new paradigm. And this is why you have to attend everything. Thank you.
Grazie mille, professore.
Thank you, Professor.
Professor Tommaso, prima abbiamo parlato di elettronica e abbiamo introdotto un po' la parte biotech per questo
Mr.
settore.
Tommaso, we spoke about electronics, but let's talk through the bioelectronics, which put together electronics and biotech. Can you tell us something about this new discipline, and what are the challenges in developing this product, and how important is the knowledge transfer here?
Sì, allora, come evidenziato prima, da un lato c'è un'esigenza
As we highlighted already,
far evolvere lo stato
on one side, you want to grow electronics, you want to allow electronics to evolve through new materials towards biotechnologies and so on. But in some industries, bioelectronics is already existing. If we consider sensors, within the medical industry, it's not by chance, there are sensors, biological sensors, which allow to translate magnitude measurements without using more invasive sensors, and they're actually able to deliver different types of information using the same sensors. And this is delivering multiple advantages. First of all, not invasive sensors on the body, because of course, the least stuff you have in your body, the better, the less it will be rejected. And then think about how they want to make a miniature size-wise. And that miniature device will already have all of these sensors embedded. The medical sensors can become really, really pricey, because on top of making it, I have to depreciate all of the investment that I made to that moment to make it possible for that product to become industrial product. So there's a market which is paying for this delta, and this is how these important technologies have evolved. If we think the renewables, the photovoltaic, for instance, is not just silica or what comes from it, but there's also plant-based materials which allow to translate sun rays into electricity. In this case, the problem is low efficiency, because with respect to a photovoltaic panel, my efficiency is way lower, and also these materials easily deteriorate over time. Photovoltaic might last for 20 years. It might then go down by 20%, and then I may replace it. If you take a photovoltaic field made of plant-based materials, will only last for a few years, if I'm lucky, because it can be subjected to a great deterioration. Still, I have a comment. In an ideal world, I would look at the sustainability, and it makes sense that the EU, governments and so on, are kind of paving the way for the world to be more sustainable. And that is because we have to think about future of our children as well. But on top of environmental sustainability, we should also consider the economic one. So it's not bioeconomy, is economic sustainability. It's a different thing. So we don't want to draw up new rules. We need to harmonize what is existing, because if we come up with new rules, limitations, and so on, we either asking company to hyperinvest, and those who can, they will do it, but then of course they will depreciate somehow, so they might lose in competitiveness, and they might not be able to do those investments. I've supported one company, they transition towards the electrification of transport. Actually, one of my companies, they work with lithium batteries, so they've literally skyrocketing in terms of results, in terms of business outcomes, of course. And I have still experienced the difficulty of many other companies that were very well positioned within the automotive chain that unfortunately are slowly disappearing, fading out. So if we talk about sustainability, introducing new technology, even in the electronics and power generation, and that is where companies are working on. Yeah, of course, we might consider roadmaps which allow environmental and economy sustainability to go hand in hand. Otherwise, we might have a better world from an environmental standpoint, but then we will not have companies anymore. And this is something that we should tackle short term as well.
Grazie mille. Dottor Bertacchi, abbiamo parlato tanto di materiali.
Professor Bertacchi, we've spoken of material, and we've given a lot of attention to them. So what are the hindrances, the obstacles for the development of this new business model in Europe, specifically focusing on materials? So carbon, for example, with all of the important aspects of organic chemistry. Well, the main problem is money, as always. You see, these technologies are going to be very expensive. Professor here spoke of PV panels, and we have other examples, chlorophyll, for example, but we have to also research its efficiency and cost, so whether it's scalable. So research, development requires years and years cost investment, and then you also have the cost of your competitor. So the petrochemical sector is extremely efficient. I always say that oil is very sexy because it's very, very attractive. A barrel of oil can be used in multiple manners. I always give this example. Why are we slaves of oil? Because with oil, we can have plenty of possible transformations into products feasible. So if you're working in biotechnology, the giant you have to fight against is a champion. The world champion on the boxing field. So you really have to fight against a very efficient opponent, even at environmental level. Manufacturing a plastic bottle is quite cheap at economic level, material level, etc. And so to reduce costs in LCA is very, very difficult. Glass will be a winner only if the recycling glass plant is closer to where you have your manufacturing factory. So it's always a question of analyzing all of these obstacles and see whether there's a win-win situation in measuring sustainability. If we compare PLA to PET, for example, well, PLA is compostable, biodegradable, etc., well, it will lose vis-à-vis PET. And even the European Union, in a report devoted to these terminology, they say no longer use biodegradable plastic. Plastic-based advantages or disadvantages. Using, for example, I live in Milan, and FAO says that by introducing organic sliders has improved organic waste collection in Milan. So these polypropylene liners versus biodegradable plastic liners is advantages for the latter. And then another study has been carried out on disposable water bottles. And so that PLA plastic bottle is useless in terms of supporting the environment? Well, no, not really. Now, PLA represents 25% of world plastic, which is 1% of world plastic, so it's very limited. So now that is LCA at the moment, but maybe when scaling it up, we will optimize PLA. So, of course, people, politics, companies look at today's situation and does not consider the implementation in the future. So, PLA is recyclable, well, potentially, but composting is considered organic recycling, but we consider also mechanic recycle. So, Total Corbion that manufactures PLA linked to chemical substances from fuels and oil says it's feasible, but there is no existing recycling pipeline. We don't have the PLA collection bin at home, because we only have one bottle out of 1 million that we use at home. So it's not developed because there's not enough PLA material, and therefore the pipeline is not developed. It's a cycle that is, you know, the dog biting its own tail. Again, looking at a leather replacement coming from vineyard waste, grape waste, chemically synthesizing and biosynthesizing these wastes. So these can be solutions, but with numerous obstacles. And so with biotech, for example, we focus our attention on bioenergy. But now we know that we have other alternatives as viable solutions. So my perception when I attended this conference in Brussels, they had the feeling that they want to solve the worldwide problems with the bioeconomy. No, we can have other solutions, not only biomasses. There are other technologies. Let's not, you know, be too short-sighted. But of course, biomaterials are a problem because we do not have plenty of alternatives in terms of biomaterials, and this is a great challenge. Luckily, the chemical industry support us. The molecules I stated earlier can offer feasible solution. And so biotechnology blended with polymers for plastics, for example, is truly crucial. So do consider hiring a biotech staff, because trust me, even if you're working in a chemical sector, you will find important connections and combinations because bottom line sales are based on chemistry.
Grazie mille.
Well, thank you. Thank you, Dr. Bertacchi. So now I have one last question to Dr. Ghilardi, Mr. Ghilardi. So how can we envisage an added value for those business models that will allow all these things to become feasible for the industry and for enterprises? So zero waste, that is the first formula that comes to mind, which we should all adopt. Zero waste in all the things we do for research and innovation. And zero waste means that if we have positive situations that comes from MICS that is then scaled up, can offer an added value solution that can be exploited by the enterprise, even if it does not belong to the core business of that company. And consider my company, for example. In our company, in our enterprise, the research we are performing tries to embrace this approach. And when that approach cannot be used in our specific sector, well, we should try and understand to which other business model it could be considered interesting and be used by other fields. And so this is why zero waste is important. I am investing and researching this. It's not useful for me. It can be used and exploited by you. And so please use this solution. Also because we do not have a lot of time. Our R&D heads in ITEMA Lab say, we have to focus on new products for 2027. We need the product, the process, and the business model have to be developed all at once, all together. And so companies, enterprises have to focus on this zero waste approach so that everything can become valuable and worth for someone else if it's not used and useful for your own core business. And this means that we have to work together, collaborate. More and more industrial groups, when they see that they have a solution that does not belong to their core business, they either spin off with other industries or try and exploit it within their core business. This is difficult to be developed in Italy because we have many small and medium-sized enterprises, but it's very valuable and used abroad. And we can only scale this up if we embrace open innovation. Then the second aspect is that we should also find an advantageous position when focusing on return of investment. Michael Chang spoke about it. It is so important to give worth to research and development and innovation, even before we found a vertical solution for the product itself. It will become more and more important if we innovate with value, because if there's no value, nobody will innovate, nobody will invest. And so innovation has to be done even before finding the vertical solution of the innovation itself. So we understood, for example, pharma. which has to envisage a huge investment. Michael yesterday was explaining that the next pharma stage will have an incubation time frame of 10, 15 years, and they are investing right now. So imagine this time span, and they want to scale this innovation even before they verticalize it.
Quindi, per tornare alla tua domanda, 1, sprechi 0. 2, cercare una verticalità insieme, e per insieme ci tengo a dirlo perché questo è un contesto importante.
Together in a very short relationship, company to company, so that they might be supported by Confindustria as well. And we have consortia in Telemach also, which is one of the most beautiful and most efficient example of intersection. I think it is including some 70 companies, 50 companies, says the president who's here. And but I'm also thinking mix, I'm thinking partnership. Partnership allows to develop a new approach that when engineer Minelli will come to me and say, you know, this cannot become a vertical on the weaving, but it might become a vertical in a different sector, then, you know, we might have the capability to do so. And I'm thinking about the Iris Lab in the electronics of power, of GAN, GAN, as Giuseppe said, will change the energy consumption. And when I think about innovation, the first thing that springs to my mind is zero waste. This is what I have in my mind. Thank you. Thank you.
Grazie mille. Abbiamo parlato di biotecnologie.
We've spoken about biotechnologies, innovation, business models, and new chains to be built. There's a lot to do, especially younger ones. Thank you so much. Thank you to the whole speakers for Roundtable, Taj, Tommaso, Bertacchi, and Ghilardi. Thank you. Thank you all.
Prego. Sì, facciamo la foto. Grazie mille ancora.
Thank you.
Sì. Per tutti gli ospiti io vi ringrazio per aver partecipato.
Thank you to all the guests for attending the third edition of Biotopics. There's a lunch being served outside. Thank you all.